This circuit drives the servo by alternating the servo's signal voltage at different frequencies. It does this by allowing the user to switch between different resistances which affect the output pulse at pin 3. Pin 3 is connected to a transistor which switches the servo signal voltage on and off at various frequencies. On the right is the schematic, while on the left is the actual circuit with labeled values and servo connections. To eliminate confusion, the switches are the same color as the resistors they activate. The servo's range of motion is from 0 to 180 degrees. When the servo signal is high for 1.5 milliseconds, the servo assumes a neutral position at 90 degrees. A lower time high moves the servo to position 0, while a higher time high moves the servo to position 180. Be careful to note that when pin 3 is high, the servo signal is actually low because current is allowed to flow through the 1 kilo ohm resistor and the transistor to ground. Oppositely, when pin 3 is low, the servo signal is high because no current flows through the transistor, so potential between the signal and the ground is around 9 volts. With this knowledge, we know that the time high for a signal, which is the pulse length sent to the servo, equals time low for pin 3, which is equal to Ln2 times R2 times capacitance 1. When the 10 kilo ohms is activated, the pulse length equals 0.69 milliseconds, which is less than 1.5 milliseconds. So the servo moves to the 0 position, which is counterclockwise. Similarly, when 667 kilo ohms is activated, the pulse length equals 4.6 milliseconds, which is more than 1.5 milliseconds. So the servo moves to the 180 position, which is clockwise. The right button activates the 10 kilo ohm resistor, so the servo should turn counterclockwise. And the left button activates the 67 kilo ohm, so the servo should turn clockwise. This is counterclockwise, clockwise.